welcome to another STARS webinar. I am David Earn, Director of Programs and Communication at STARS. For those of you who are here for the first time, STARS webinars are interactive discussions about future-oriented topics such as leadership, geopolitics, technology, climate change, and health. A select group of people is attending the webinar live, asking their own questions, and hundreds more will watch it later on as a recording in STARS Insights or on YouTube. Good morning, good afternoon, and good evening to all of you. Today we talk with Professor Dr. Roland SIEGWART about how the rise of the robots will change virtually every aspect of our lives. Roland is full professor of autonomous systems and head of the Institute of Robotics and Intelligent Systems at ETH Zurich. He is also the founding co-director of the ETH Zurich and a board member of various companies, including Comax and NZZ. Furthermore, as a strong promoter of innovation and entrepreneurship, Roland is a co-founder of half a dozen spin-off companies, and he is also a member of the STARS scientific board. His research interests are in the design and control of robot systems operating in complex and highly dynamical environments. Roland's major goal is to find new ways to deal with uncertainties and enable the design of highly interactive and adaptive autonomous robots. Prominent application examples are personal and service robots, autonomous micro-aircrafts, walking and swimming robots, and driver-assistant systems. Good morning to you, Roland, and thank you for joining today's webinar. The format of today's webinar is as follows. Roland will start with a 10-minute opening statement and a few slides, sharing with us what he sees as the most exciting developments in the field of robotics and explaining what kind of challenges this next generation of robots comes with. We then have about 20 minutes for discussion. If you have any questions for Roland during his presentation or thereafter, please use the Q&A feature below to type in your question. Without any further ado, I hand over to you, Roland. The screen is yours.
Thanks very much for your introduction. It's a great pleasure to be here and give you some insights about robotics, and especially have a discussion with all of you listening here. So the question is, how will robotics and robots transform our future? So let me really quickly do an introduction so we can warm up for the discussion we will later have about where robotics was up to now and what the future will be the focus of. So we know all these type of robots, which are assembling our cars every day, 24 hours a day, 365 days a year. If you imagine this would have still to be done by humans, I think it would be extremely difficult. Robots are in this environment much more precise, much more reliable than humans. And on the other hand, we are probably also happy that robots do this. Imagine that you would have to spray paint cars 24 hours a day. Humans would have to do this. This is a very unhealthy environment. But what you can also see on this short video is that these robots are actually operating in an environment which is extremely structured. There is no humans there. The cars are really moved very precisely to the next station, and the robot can more or less blindly, only by moving to a certain spot, do their work. So what the future of robots is robots which are different than industrial robots, which often are called service or personal robots. And this might be at one moment this type of robot. This is a robot or video, YouTube video from Boston Dynamics, which shows probably a little bit what the future could be. Of course, people watching this YouTube video think, yeah, probably I can get one of these robots for Christmas, and then I have nothing to do at home anymore. Unfortunately, I have to disappoint you. This is a video where most of the stuff is actually teleoperated or precisely pre-programmed. We are still pretty far from having these type of robots in our highly unstructured environment, in our homes, but also professional lives. Why is this so difficult? You can see again a video of a robot, which is already a couple of years old, but today we are not much further, which does a typical household job. You can see this robot, this video runs 50 times the speed, and it's still not so fast. So our daily environment, in contrast to industrial environment, is much more complex, much more diverse, and multimodal. So the robots in our daily environment have to deal with a lot of uncertain information, a lot of partial information, and still have to take the right decisions. Furthermore, they have to do actually force controlled interactions. So they need not only to see, but they have to feel and understand the environment. They have to touch and manipulate objects with force control, where we humans are extremely good. We are very bad in precise position control, but we are fantastically good in force torque control. And especially what we have this capability, for example, with our fingers to really feel the interaction and to do very fine tactile manipulations. Furthermore, today's robots are programmed by specialists. And at one point, we need robots which actually do just what we want them to do. Just tell them, clean up my kitchen, and then they will do it. But this, if you start to think about what this means, how much understanding you need to do this, then you can probably imagine that robots are still far from this. Of course, they have to learn and adapt. And if you look at robot systems, sometimes people speak about robots and machine learning in the same as the same concept and technology, but robots is much more. Robots need machine learning and artificial intelligence, but they need also sensors, actuators, and robot concept. So it's a much more complex machine than just an AI system which does data analytics. So I tried once to put together more or less the complexity of tasks robots could have in our daily environment, and a little bit of timeline. Of course, it's very difficult to predict, but I have on one axis, on the x-axis, you have the complexity of the environment, which can be a 2D situation, which, for example, a freeway is somewhat 2D, can be represented by 2D. Or up to a 3D environment with a very dynamic environment where you have a lot of motions and so on. And in the other axis, you have the complexity of the interaction, going from just autonomous navigation, going from A to B, up to this tactile manipulation of objects and elements. And I want to only pick out probably 2 or 3 examples. So autonomous cars on the freeway, it's somewhat solved today. It's still the question how to really industrialize this up to the end and how regulation will actually deal with this. But as soon as you have an autonomous car, which is driving in a city, for example, in Europe, which is very dense and very complex, and you have a lot of interaction with humans, you have to understand signs of a human pedestrian next to the road. And then all of a sudden, an autonomous car becomes also an interactive car, interactive in the sense that it has to understand situations. So this is further down the road. So until we can cover all typical situations with autonomous cars, it will still take some time. And you can see at the upper end, you can see household robot. Interestingly, I would consider that cleaning up the kitchen is one of the most complex tasks for robots, which, of course, you typically don't do a special education to clean up your kitchen. You just learn this. Humans are extremely good. Robots are not good in this. And so there is really a difference what robots can do well and what humans can do well. And I'm happy to discuss this further on. And with my last slide, I would like to give a little bit the fields where I think robots can do a wonderful job in the future. Of course, there is much more. I don't have household on this list. It's, I think, using robots in the environment where, more in professional environment, where it can help to avoid that people are put at risk, that people have to do dangerous jobs, which is really not good and dangerous for their life. And this can be agriculture and forestry. Agriculture robots can really survey fields and have then a much more sustainable agriculture, smart farming. Then search and rescue, inspection, surveillance. Very often you have to search people, for example, in Switzerland, in the mountains, which are somewhat lost. And there, people are at risk only for the search. And robots can do this probably much better. If you have bad visibility, you can risk, for example, a drone, but you should not risk a helicopter with a human pilot in it. Construction had little innovation in automation in the last years, but construction side, we know it's dangerous and it's also not very healthy for the body. And I think there we'll hopefully have robots which can help humans. Logistic and transportation, up to these autonomous cars, which are largely discussed, and everything, for example, which is subsea, where humans are not really built for. We are not built for diving more than a couple meters, and it's where robots could do it much easier. So in general, I think humans and robots are quite complementary. Robots are very precise, are not tired. You don't have to care so much about the risk of the environment because you will not lose a life. And humans are creative. We are extremely good in understanding situations and so on. And in this sense, I think humans and robots are extremely nicely complementing it. And I hope that in the future, robots will do the dumb and dangerous jobs, for example, in mines or on construction site, and humans do the more jobs where we use creativity and understanding of situations. With this, I would be happy to start discussing with you and go more in depth on some of these topics and what robots can be in the future.
Thank you very much, Roland. Let me just take back control of the screen. We already have a first question from Christoph Lindenmeyer. He's the CEO and Vice Chairman of the AO Foundation. He's asking about robots for surgery. How do you see the future of robots for surgery, for medical application?
Yes, I think this is a perfect example of exactly what I mentioned before. Humans and robots perfectly complement each other. So in a lot of searches, you have to be very precise and hold a position very precisely. This is perfect for robots. But human bodies are not unique. So they have all little variances. Humans are much better to deal with this. We are much better as a medical doctor. They are much better in having this tactile interaction and feedback. So I think robots and medical doctors will more and more incorporate in the future in the operation room, where the human takes the important decisions and does, at least for the next 10 years, probably the more very delicate, very fine tuning jobs. And the robot does all the jobs where we need a high precision and positioning of position. So I think up to now, medical robots were especially, for example, hip replacement was done with the support of robots, where exactly the robot is doing a very precise drilling, which is better than humans, but the human has still to for example, open the area where you can replace the hip. So I think it's a perfect field, and I'm not worried that medical doctors will not have any jobs anymore. Probably it's even getting more interesting for medical doctors because they can do and concentrate of the most critical and most important parts of the job.
The next question comes from Tony Reis, former CEO of Swisscom. He's asking about the application examples in warfare. What is going on with robots in the arms industry?
In the army?
Yes.
Yes. Yes. So hello, Tony. It's great to have you here. Yes, of course, this is a field where we are not really active. We do some collaboration, but more for search and rescue with the Swiss Army. But I think robots will play an even more important role in army in the future. And there is always this discussion, should we have some clear restrictions? I think it's good if we find this. But it is not our task. We are not the specialists to do this. But for us, it's important to show and demonstrate what the risk could be and what technology is available today. And you know that drones are used in the army since quite a while. They're getting more autonomous. And for example, this discussion about who takes the decision to really shoot, is this up to now, it should still be a human, but at one point, probably robots will be much better and in doing this, and humans will be out of the loop. I think it's dangerous. We have to, as a society, discuss this and find a jointly really solution that robots are not really putting even more people in wars into very unlikely situations.
The next question comes from STARS alumna Sunny Chung. She is a tech regulatory lead at Roche in Singapore. She's asking, Can robots learn, and what implication does this have for technology advancement?
That's a very good question, because there is a lot of discussion about learning. We are now in the decade of deep learning. And it's wonderful in a way what we can do today, thanks to a lot of calculation power, but also about advanced algorithms in learning from data. But the question is, what is actually the definition of learning, first of all? So we as a human learn actually in a context, in a task, and this is getting much more difficult. So learning actually from looking at 100,000 images and to learn what is a cat in this image and what is a dog, this we can do better and better today with computers. But if you have to learn to clean up the kitchen, it's getting extremely difficult. So because there is so many elements involved, because in principle as kids have also learned this. By the way, as kids have to learn about 14 years until they can hold a cup with the optimal force. Optimal force means to crush it not too hard, but hold it enough that it doesn't fall. Adults can do this with about 10% extra force so that it doesn't slip. So this is tactile interaction, comes together with an understanding of the whole situation. So all these elements are at one point so complex that we don't have the tool today to learn this all at once. But where learning, where we do a lot of this learning helps, for example, to learn the best features. Features are typically used as elements in an image sticking out, which you can easily find again if you have an image from a different view of the same scenery. Learning the best features, this we can do with deep learning technology, and this can really improve the robustness of navigation. But this, which is called very often black box learning, end-to-end learning, this I think we are not ready, and I'm convinced that also in the next 10 years we cannot learn that an autonomous car can learn end-to-end to drive. There is sometimes some spectacular results or demonstrations so that the car learns to stay on the street. That's okay. But in principle, the car has a task. It has to go to a special place. At one point, it has to learn also, where should I take a left turn? What is the whole combination of this? And this is much more complex than only have more or less one output, stay on the street. So we can learn subtasks, and in some situations this helps a lot, but we cannot learn the entire task. And by the way, also nature and humans, we learn quite for a long time, and we have much richer sensory elements. So coming from seeing, hearing, smelling, and also tactile interaction, which today's robots don't have, and this is mechanically also very difficult. So there will be not so easy to have robots which learn as easy as you.
We have a question from Matthias Gilner, who is a executive board member at Hilti. He's asking, are all the videos from Boston Dynamics and the like, playing soccer, for instance, are they fake or fabricated in the sense that the robots are remote controlled?
So there is a couple of videos from Boston Dynamics which are extremely expressive. And by the way, it's also really impressive what they're doing. I think they are not fake. I think Boston Dynamics, to my knowledge, at least what I have seen up to now, do it in a way serious. The problem is only that you will watch the YouTube video, but nobody reads what is below. Typically, they tell you what is below. And of course, this is in research, but also as a company, you typically show the successful examples. But Boston Dynamics shows also sometimes video with the failures. So you have, for example, this human type of robot which doing loops and so on. You can also find some videos where it fails. So I think most of this stuff is still strongly pre-programmed and tuned for demonstration. If this would be feasible, then we would have immediately plenty of robots. In all the logistics centers, we would be happy to have robots, but they are not ready. But they're making big progress, and I think this video show more or less typically what might be possible in 10 years from now as industrialized products.
The next question comes from STARS alumnus Daniel Bircher. He's the CEO of Zurich Airport Asia, based in Kuala Lumpur. He's asking, how do you see commercial drone development, for example, for last mile distribution from airports to customers?
Yeah, so I have probably a very distinct message about the drones. Even if we are really doing, the most research I'm doing is in drones. I think we are leading a lot of this technology development. But I think we have to be careful about using the drones in the right place and probably doing some stuff not. And especially delivering products to an end customer from a logistics center. This might be interesting if you are at a very remote place. So in Switzerland, you have probably an alpine hut and you deliver something up there. So this is much more sustainable and probably very good if you do this in the future instead of having a human piloted helicopter. But imagine you have all this delivery of this big logistics centers in the city by drones. This will be on one side not very sustainable and efficient, but even more, and I think this is the critical element, it's extremely noisy. People always think drones are small, they are not noisy, but as soon as you carry big loads, they will have a certain noise. But of course, it's not the same as a big helicopter, but if you have hundreds of them or thousands of them, this will be catastrophic. So I think we should hopefully wisely use this. I see a lot of fields, but it's not a mass market where, in principle, all the parcels will be flown to my home. But in some fields, it might be extremely good and extremely reasonable to do this with drones.
We have a question from Hans Hengartner, a co-founder and a board member of STARS. He's asking you about literature search in science by robots. Does it exist yet, and is it reliable?
Yes, hello Hans. It's nice to see some of my good friends here. So, of course, some people call this robot. I would not call it robot. For me, a robot is with a physical body. But of course, some people call also the search machines and stuff with robots. But this is more or less software algorithms. Of course, literature search is already done, I think, extended with AI. So I always tell, when I was doing my PhD, I had to go to the library and pick up a book, make copies, and it was extremely difficult to find. Today, I think all my PhD students never have been to the library because they have search machines. Google, for example, is having this Google Scholar where they search permanently all the publications. They then do automatically extraction of how often they have been cited, and they calculate then the citations index and so on, which is, to my understanding, very reliable. And I think there is a change with all this field. I would assume that at one point, publications are really quite different, so that people just put their knowledge and their publication on the web. And somewhat a partially automated system will actually bring this to the people which are interested, and then people probably will judge which are publications on high quality.
We have a comment and a question from Geoff Richards, who is the Executive Director of Research and Development at the AO Research Institute in Davos. He's writing, our whole network is surgeons. So robots can help, like you, Roland said, but just help. And his question, if a robot is in charge of a machine and there is an accident, where is the responsibility and accountability?
I think this is probably a difficult question because it really depends on the different examples. But I would like to take the example which is most often discussed in cars. Autonomous cars will appear more and more on our streets in the next 10 years. And then there is the question, who is responsible if you take a wrong decisions? I think at the end, it's probably the car manufacturing, but this at the end is this insurance, and the legal or the authorities will decide who has responsibility. But it can for sure not be the human anymore because he's not in the loop. But I don't think that it's so critical because in a way, I think we will then once this is released on the street, fully autonomous driving, at least, for example, on freeways, then this is so strongly tested that we can hopefully clearly prove that the risk of having an accident is probably 10 times lower. So we are saving a lot, and we have still a remaining risk. And for this risk, somewhat somebody has to financially be responsible. And for the decision, I think it's the machine or the builder of the machine which has a certain responsibility. But in all these probably remaining much fewer cases, I think at the end we will see that these are situations where nobody could have decided right. And hopefully we will only release cars in the public streets fully once we are sure that these cars are much more reliable than humans. And I'm convinced. I'm always skeptical. It will take more time as we think, but there will be a time where we will discuss: are humans still allowed to drive? Because robots will be safer at one point than humans, because this is a repetitive task. Robots will actually not be distracted by a phone call. They just drive and concentrate on driving. So at one point we will discuss the opposite. Why should a human be allowed to drive? Because we have autonomous cars which are much safer.
The next question comes from STARS alumna Beatrice Fischer. She's the owner and managing director of BF Advisory and Solutions. She's asking, how do you see robots in the gastronomy?
Yeah, so I think gastronomy, there have been already some examples. There are probably different types of gastronomy. I think there will be the high-end gastronomy where we humans would like to really be treated as humans by another human, and this makes the difference. And there I don't see robots, at least in the interaction with the client. But on the other side, if you look at these fast food chains, there in principle you have little interaction. So this will be more and more automated, and there is already some activities in this direction. And so I think it really depends on the application field. So if you go through a drive-through today, you are actually anyway not really interacting with people directly. There is actually this interesting example where in Japan they had a hotel which was somewhat fully driven by robots, which they closed again because they really realized. So I personally think I prefer to have just a machine where I can more or less select which room I want for the hotel. I don't need a robot speaking somewhat strangely to me. And for only going to sleep there, it's okay. But if I want to have an experience with my family, with my wife in a hotel, then I would like to have at the front desk a person who is answering my questions, can understand what situation it is, and I think this cannot be done by robots, at least in the next 10, 15 years.
We have a question from STARS alumnus Daniel Bach. He's a senior consultant at Learn Singapore. He's asking about the progress of robotics and robots. Is this progress effectively determined by the progress in computing capacity?
No, as mentioned on one of my slides, I think this is dangerous. And of course, those people working mainly on learning and these algorithms, they typically claim, yes, we'll soon have very intelligent algorithm, and then everything will be done. This is clearly not the case because robots are physically interacting. So they need sensors, they need the appropriate sensors to do this. They need tactile interaction. So we are extremely far from having this haptic we have with our hands. And this is extremely difficult to build. So there is a lot of research, little progress. But a lot of our tasks, daily tasks, are depending on our hands. So as long as we don't have hands, intelligence or whatever algorithm is not able to do something useful if you don't have the capability with actuation and sensing of our hands. I think there is a lot of elements which are more than just calculation power and algorithms.
We have another question from Michael Graf von Medem. He's the general manager of Fishhole. He's asking, is the competition among different nations helpful, or rather harmful? For instance, China buying up German robotics companies.
Of course, I'm always think that competition is helpful as long as it's done fairly. There is, of course, with this recent situation, sometimes a little bit unfair competition where all of a sudden a country decides. I think if it's an open competition, it's good. Of course, there is probably cultural differences which we have to understand, and I think a lot of people don't understand. What I think is China is much more long-term thinking. And what means that, for example, this situation with the German company KUKA, by the way, there was also a smaller company in robotics from Switzerland which had about the same situation. They are willing to invest more. So at the end, the person or the consortium selling the company will probably still go for the best price. And I think China is much more thinking long term. They know that this technology will be important in 20 years from now. And so they're willing to invest more and to pay more for the company than Europeans and especially Americans, because they are more on short-term returns. And so then I think this is something we have to understand. I would be very happy if people, societies really start to think much more long-term. Quarterly report in a company which has high technologies doesn't make sense. In a lot of situations, you know that it will go up and down. Investments for developing a next generation of robot takes typically 10 years and plus. I can show you plenty of examples. So if you have a CEO which is only staying for 2 years and actually optimizing quarterly report, then you will, in principle, end up not investing in R&D. But this will actually bring the company to a very delicate situation, but probably only after 5 or 10 years. And I think this is something we hopefully start to change thinking. So this long-term, this is also infrastructure. Happily in Switzerland, we have still are willing to invest in long-term. We drill tunnels through the Alps, which is a huge and crazy investment. And if you would this only do for a short term, you would say you are totally stupid. But I think it will pay off. This will allow us to really reduce carbon by having more on the railway, and this is something which pays off.
We have already run out of time, sadly, but I'd like to take one final question from the audience, and the question comes from STARS alumna Sonja Wolkopf-Wald. She's the CEO of Greater Zurich area. She's asking, how does Switzerland perform? Where does Switzerland stand in the global robotics competition?
I think we are doing extremely well. So we have also some people from outside. Of course, yourself probably think always that we are doing a good job, but there are also people from outside which quite often speak about the Silicon Valley of robotics. This, of course, this new type of robots starts more in the research labs of the university. So ETH and EPFL are really at the forefront of this, worldwide forefront of this technology. Not the only one, there's a lot of competition also, but I think we are doing extremely well. We are also doing well in the last 10 years with the number of startups in these fields. Now we have to prove that we can also scale. This is the most critical element. And of course, Switzerland is I don't speak of scaling that we need plenty of companies which grow up to X billion, but we have to have companies which scale to a reasonable market so that it's a solid company. We are doing much better on this end. So I'm personally also involved in a lot of these activities, like also with the ETH Zurich, which is a support from Hans-Jörg Wyss, which allows us to really scale early on. And I think this we still have to do. We need also the support from a lot of people from the financial industry, but also private person, which believe in long term. And again, it comes to long term. A startup will actually be profitable in the best case, very nicely profitable and stable 10 years after start. This is very complex technology. So you need people which are willing to invest for long term.
Before we let you go, I'd like to ask you one final question on the startup scene that you just mentioned. You co-founded half a dozen spin-off companies, and you are certainly a role model for many more entrepreneurs and innovators. So in your experience, What does it take for a robotic startup to succeed?
I think it's, first of all, because it's very complex technology, you need the best brains. Of course, one part of the best brains is the engineers and the nerds and whatever in this field. And then you have to combine them with the people which have the entrepreneurial feeling for the market. So to bring the right people together. And of course, in global, totally, overall, it's always about the dedication of these people, because starting a company and making it successful is a hard job. There was once a guy saying that the most important thing for an entrepreneur is that he's healthy and can also, for 1 week, survive with very little sleep, because you will have phases like this. But on the other side, it can be extremely rewarding. You have to be able to survive pushbacks, to have probably really a right team where you still, if you have a failure, that you can get on the legs fast and do a better job in the next trial.
I read somewhere that startups from ETH have a very high survival rate, with about 80 to 90%, I believe, of startups surviving in the long term. In the US, however, it is claimed that only 1 out of 10 startups actually make it, they actually succeed. How do you explain this very stark contrast?
Yeah, so of course, this is a view on the ETH startup, which is already different. If you would look at the MIT startup, it's probably also a different number than the 1 out of 10. But I think it shows probably also a little bit a cultural difference and some issues. So I think US is in one extreme. They typically pull or push a lot of money in an idea, and either they succeed and become really big, or they're out. Now the European, and especially also Swiss culture, is more that we take one step by the other. But we have a very solid technology at the beginning, and this is what typical universities can offer. And this will allow us to develop. Typically, we have a lot of these companies which will survive, which is about 90% really, are ending up as world leader in their specific field. But too many of them don't scale. And I'm not speaking of, again, of scaling to a multi-trillion or billion company, but to a reasonable size where you can survive, which I think within 10, 20 years, you should scale up to 500, 1,000 people. And this scaling takes also a risk, because scaling means that you have to get investor involved. You give up a little bit of control, and this is what Europeans don't like so much. So I think we have to learn. We don't have to do the extreme case, but we should learn to take a little bit more risk. This is actually what we are doing now also with the ETH Zurich to support these companies. We are doing better, I think, and I'm pretty sure that we will probably have a little bit more failure in the future, but also more companies which scale to reasonable size, which really generate wonderful jobs for Switzerland, Europe, and the world.
With that very fitting closing statement, I would like to thank you very much, Roland, for your time and for sharing insights with us. Thank you, Roland.
Thanks very much. It was a great pleasure. Bye-bye.
I'd also like to thank all our alumni who participated in today's webinar. This was our last webinar in this year. I hope to see you again in 2021. In the meantime, take care and stay healthy. Thank you and goodbye.